Welcome to CG in the Rank Zone. Today we are going to do lecture number 4, that is atomic structure. So before going to the topic, I want to revise for you. So we are revising now. So important relation in Planck's quantum theory: E is equal to NhC by lambda and E is equal to N into H into nu, where N is called number of photons, H is called Planck's constant, nu is called frequency, and NhC by lambda, where C is called velocity of light. And photoelectric effect already we know. Kinetic energy is equal to H into nu minus nu naught. Kinetic energy is equal to H into nu minus nu naught, where nu is called frequency, nu naught is called threshold frequency. So based on this, now I would like to do certain worked out examples. Next, example 1. Calculate the energy per quantum of light associated with the wavelengths 500 nanometers and 720 nanometers. So we already know E is equal to H nu, means writing the formula on the board. So E is equal to H nu. In this problem, they have given lambda and they are asking us to find energy per quantum of light. So E is equal to H nu implies E is equal to H into C by lambda, since nu is equal to C by lambda from wave theory of light. So it implies E is equal to H into C by lambda, where C is called velocity of light and lambda value is given. So straight away we can find energy per quantum of light. So after finding this, you will get the answers. You can work it out. H value is 6.625 in 10 to the power of minus 34. C is 3 into 10 to the power of 8 meters per second. And lambda 500 nanometers, you have to convert them into meters. 500 into 10 to the power of minus 9 meters, because 1 nanometer is equal to 10 to the power of minus 9 meters. 1 nanometer is equal to 10 to the power of minus 9 meters. So after substituting, for A, you will get 3.975 in 10 to the power of minus 19 joules. And for B, we will get 2.76 in 10 to the power of minus 19 joules. Is it clear? Next question. The work function of metal is 5.2 electron volts. To emit a photoelectron of zero velocity, here zero velocity is important, from the surface of metal, what should be the wavelength of the incident radiation? Since already we know photoelectric effect, kinetic energy is equal to Ke is equal to H nu minus H nu naught. This H nu naught is called work function of the metal. And kinetic energy is given 0 because it has 0 velocity. So by this you can write 0 is equal to H nu minus H nu naught, that is work function of the metal, H nu naught, that is 5.2 electron volts, 5.2 electron volts. And here one important conversion is 1 electron volt is equal to 1.6 in 10 to the power of minus 19 joules. So if the answer is given in joules, you have to convert this electron volts work function into joules. So by this we can write, they are asking us to find what should be the wavelength of the incident radiation. H nu is equal to 5.2 into 10 to the power of 1.6 10 to the power of minus 19. And since already you know nu is equal to C by lambda, nu is equal to C by lambda, H into C by lambda is equal to 5.2 in 10 to the power of 5.2 into 1.6 10 to the power of minus 19 joules. So you know the value of H, you know the value of C. From this you can find out lambda. So lambda is equal to, lambda is going this side, lambda is equal to H into C by H into C, that is 6.625 in 10 to the power of minus 34 into C value 3 in 10 to the power of 8 meters per second divided by, that is 5.2, that is electron volt work function, is 5.2 in 10 to the 1.6 into 10 to the power of minus 19 joules. So by calculating, you will get the answer in joules. So in this way you have to do. Suppose if the answer they have given in electron volts, straight away no need to take that is 1.6 10 to the power minus 19, just by 5.2 only I have to take. So let us see what the answer they have given, whether they have given answer in electron volts or joules. So checking the answer. So they have given nanometers, so definitely you have to convert them, because we have to convert the electron volts into joules, because all other things are measured in SI units. So we have to do that calculation, and then you will get lambda value, that is 238 nanometers. I hope this is clear for you. This work function of metal is given, and they're asking us to find lambda. Next question. When a certain metal was irradiated at frequency of 3.2 10 to the power of 16 hertz, the photoelectrons emitted have twice the kinetic energy did the photoelectrons when the same metal was irradiated with the light of frequency 2 in 10 to the power of 16 hertz. Calculate the threshold frequency of the metal. This is very, very important model. They are asking us to find threshold frequency of the metal. Since the metal is the same, but only it has two frequencies, they are given two frequencies. When a certain metal was irradiated with the light of frequency 3.2 10 to the power of 16 hertz, the photoelectrons emitted had twice the kinetic energy as did the photoelectrons. So for the frequency of 2 in 10 to the power of 16 hertz, the kinetic energy is taken as 1. And for the frequency, when the light of frequency 3.2 and into 10 to the power of 16 hertz is given, the kinetic energy is taken as 2. So from this, you can easily find out the threshold frequency. So how to find out? I'm just giving the idea. Kinetic energy 1, Ke1 by Ke2 is equal to H nu, H into nu minus nu naught. H into nu minus nu naught, that is first case, by H into nu 1 minus nu naught. Here nu naught is same. Nu naught 1 is not required, nu naught only, because threshold frequency for the same metal. So by this you can write nu is called 3.2 in 10 to the power of 16 hertz, and nu 1, nu 2 we have given. So frequency 1 is, that is equal to H into H gets cancelled. We can write Ke1 by Ke2. Ke1 is 2 by 1. 2 by 1 is equal to, because first case, nu 1 is 3.2 in 10 to the power of 16 hertz minus x divided by nu 2 is 2 in 10 to the power of 16 hertz minus x again, because the second case also it is threshold frequency of the same metal. That is most important. By solving, this is 2 by 1 is equal to 3.10 to the power of 16 minus x by 2 in 10 to the power of 16 minus x. By solving, you'll get x value. You'll get x value. I hope it is clear. And that x is nothing but what? Threshold frequency of the metal. So x is equal to threshold frequency of the metal. So easily you can get it by using the equation. Just this 2 in 10 to the power of 16 minus x can be sent to that side, and this 3 in 10 to the power of 16 minus x, if you interchange, you'll get the answer straight away easily. There is no quadratic equation also required for this. Just interchange the values, you'll get the answer, and the answer is 8 into 10 to the power 15 hertz. They have given the answer 8 into 10 to the power 15 hertz. Definitely you'll get the answer if you follow the formula which I have given in the previous one. I hope this is clear for you. Next question. Next topic is here. What is stopping potential? This we have not discussed, because this stopping potential you'll get in physics also, but here it is there in our syllabus. So that's why in NCERT book. So I'm doing it. Stopping potential is a minimum potential that must be applied to stop the photoelectrons. So as we already know, during photoelectric effect, by the radiation of light, ejection of electrons takes place from the metallic surface. This stopping potential is the minimum potential that must be applied to stop the photoelectrons. So to stop that photoelectrons ejection, we have to apply potential difference. Potential difference is measured in volts. That is called stopping potential. So the energy of the potential applied to should be equal to the kinetic energy of the photoelectrons. So if the energy of potential is not equal to kinetic energy of the photoelectrons, the stopping potential is of no use. So E into V, there V is called volt, and E is called charge of electron, is equal to H into nu minus nu naught. The formula for this is equal to 1.602 10 to the power of minus 19 into voltage V is equal to H into nu minus nu naught. So remember this formula, very, very important. Next. Example 4, based on photoelectric effect, stopping potential. So the ejection of photoelectron from the metal in the photoelectric effect experiment. The ejection of photoelectron from the metal in the photoelectric effect experiment can be stopped by applying a voltage of 0.65 volts. When the radiation of 225 nanometers is used, calculate the work function of the metal. So already we know voltage is given and nanometer is given, and calculate the work function. Radiation of 225 nanometers, that is lambda, is given. So they're asking us to find work function of the metal. So easily can find. So E into V. So that is V is equal to H into nu minus nu naught, because E into V is nothing but E into V, that is charge of electron, small e. If I go to write, it is small e. So this is the formula for finding for this stopping potential, E into V. So H into nu minus nu naught. So this is equal to E into V is equal to H into H nu minus H nu naught. And they're asking H nu naught work function. So H nu naught is equal to Hc by lambda minus EV. So simply you can find out this formula, and E into V is given. Since work function is also measured in electron volts, so straight away you can get the answer. You know the C value, you know lambda value, you know H value. By substituting this value, you will get work function of the metal. I hope this is clear for you. So again, I'm telling you this problem. They are given stopping potential as 0.65 volts, and radiation of the light is given, that is lambda is given 225 nanometers. We have to convert that nanometers into meters. Anyway, you know that. So calculate the work function of the metal. So from the stopping potential formula, we know E into V is equal to H into nu minus nu naught, where E is called charge of electron, V is called volt, and H is called Planck's constant, nu is called frequency, and nu naught is called threshold frequency. By expanding this formula, EV is equal to H nu minus H nu naught. And this H nu naught is called work function, since already we know. So H nu naught is equal to Hc by lambda minus EV. So in this way, you can find out the answer. And the work function of the metal will be in electron volts. So straight away the answer is 3.01 electron volts. Next. I hope it is clear now. So moving to next topic. So important relations in Bohr's theory. So already we know MVR is equal to NH by 2 pi. That is angular momentum of electron in an orbit. Angular momentum MVR is equal to NH by 2 pi from Bohr's theory. This formula is most important. MVR is equal to NH by 2 pi. So simply if they ask angular momentum, then we have to write. And radius of nth orbit is also given. R is equal to A naught into N square by Z. Z represents not only for hydrogen atom, but hydrogen-like species. Atomic number. So for hydrogen-like species, you have to use Z. And V is equal to 2.18 or 2.19 10 to the power of 6 Z by N meters per second. This is velocity of electron in the orbit. And energy of electron in the orbit is given by 2.18 10 to the power of minus 18 minus 2.18 10 to the power of minus 18 into Z square by N square. Suppose if it is given in electron volts, we can write it as minus 13.6 by N square into Z square. And delta E is equal to RH into, that is change in energy, is equal to RH into 1 by N1 square minus 1 by N2 square. So this is called change in energy of the photoelectrons. So I hope these formulas are clear from Bohr's postulates. Next, what is orbital frequency? So you know orbit. Now orbital frequency of an electron is the number of revolutions of electron per second. Orbital frequency is nothing but number of revolutions of electron per second. So this formula is nothing but V by 2 pi r. So velocity by circumference. And orbital frequency is equal to, since velocity of electron is 2.19 into 10 to the power of 6 into Z by N, that is orbit number, by 2 into pi value is 3.14, and R value is 5.29 10 to the power of minus 11 N square by Z. This 5.29 how we got, since radius of first orbit R is equal to 0.53 angstroms or 0.529 angstroms. So that's 0.529 angstroms. We can write it as 5.29. So here they have mentioned 5.29. So that's why we are doing 0.529 angstroms. So this we can write as 5.29 into 10 to the power of minus 11 meters, because 1 angstrom is equal to 10 to the power of minus 10. So into 10, if you do 5.29, it will become. So this only they have mentioned here, 5.29 into n square by z. This is the formula. This is the formula for orbital frequency. I hope this you can understand. What is orbital frequency? Number of revolutions of electron per second. Number of revolutions of electron per second. I am writing this formula. You also write down. This formula is very important. Next, we can apply problems based on this also. So it is the first orbit. So next question. Orbital frequency is given by simple formula directly. 6.59 into 10 to the power 15 into z square by n cube. 6.59 10 to the power 15. After calculating that, z square is common. N cube, n is called orbital number. Orbit number, sorry. For hydrogen, z is equal to 1. So the ratio of orbital frequency in two different orbits is x1 by x2 is equal to n2 by n1 whole cube. N2 by n1 whole cube, because this is same. N is proportional, so inverse proportional. So you'll get n2 by n1 whole cube. Next question. What is the time period of an electron? The time taken by electron to complete one revolution in an orbit is called its time period. It is the reciprocal of orbital frequency. Orbital frequency is v by 2 pi r. So here 2 pi r by v. Time period of revolution of an electron in the nth orbit is given by 2 pi r by v. Now problems based on this. Calculate the number of revolutions made by electron in fourth Bohr orbit of hydrogen atom. So here already we know 6.5 in 10 to the power 15 orbital frequency is nothing but, they are asking number of revolutions means nothing but orbital frequency only. So orbital frequency is equal to 6.59 into 10 to the power 15 into z square. 6.59 10 to the power 15 into z square by n cube. So if you substitute this formula, you'll get the answer. So n cube is fourth orbit. So fourth is a 4 cube. 4 is a 16, 16, 4, 64. That is equal to 6.59 10 to the power 15. Z value, it is hydrogen atom, so it is 1. So 6.59 10 to the power 15 into Z value 1 by n cube is 64. So if you substitute this, you will get the answer. 6.59 10 to the power 15 can be taken as 65.9 into 10 to the power 14. So 65.9 by 64. 65.9 by 64. You'll get it as 1 point something into 10 to the power 14 hertz. 1.02 10 to the power 14. So we'll see what they are given. Second inverse also you can write. So what they are given in the answer, we'll see. Exact answer I told by using calculator, but what is the answer, we'll see now. So it is 1.0 10 to the power 14. Second inverse is the same thing. Hertz or second inverse is same. So I hope this is clear. 6.59 10 to the power 15 into z square by n cube. This is the formula for finding number of revolutions made by an electron in fourth Bohr orbit of hydrogen atom. Again, I'm writing the formula. 6.59 number of revolutions is equal to orbital frequency. That is nothing but what? Orbital frequency. So orbital frequency is equal to 6.59 into 10 to the power 15 into z square. This z square for hydrogen-like species by n cube, where n is called orbit number. So I hope it is clear. This formula is most important. This is the answer. Our heads both are same. So next question. The ionization energy of helium ion is 19.6 in 10 to the power of minus 18 joules per atom. calculate the energy of first stationary state of beryllium plus 3 ion. So you already know energy of electron in the nth orbit is equal to En is equal to minus 2.18 or 19, 2.19 into 10 to the power of 18 minus 18 joules per atom into z square by n square, where n is called orbit number. Substituting this formula, so minus 2.18 10 to the power of minus 18 z square, here z value of beryllium is 4 square, that is 16, by n square is first orbit, so n is 1 only. So minus 2.18 10 to the power of minus 18 into 16. So you'll get the answer minus 2.19 10 to the power of minus 18 into 16 by n square. This one. So after that, you'll get the answer. So next question. I hope this is clear for you. Just note it down. Next question now. So answer for this is 7.84 10 to the power of minus 17. So if you do simplification, you will get the answer say easily. So next question now. What electron transition in the helium ion? What electronic transition in the helium ion would emit the radiation of same wavelength as that of the first line in Balmer series of hydrogen atom? This is very typical question. What electronic transition in the helium ion would emit the radiation of same wavelength as that of first line in Balmer series? So first we'll calculate the wavelength of first line of Balmer series by using Rydberg's equation. So 1 by lambda is equal to, first line is alpha line, 1 by lambda is equal to RH into, that is Rydberg's constant, into 1 by n1 square minus n2 square. This is for only hydrogen atom. For hydrogen-like species, 1 by lambda is equal to RH into Z square into Z square into bracket 1 by n1 square minus 1 by n2 square. That is for hydrogen-like species. Here into is not required because already we kept bracket. So here in the first case we can find out lambda. I'm rubbing this now. Just rub it out because space is not there. Z square is important over there. For hydrogen I'm not writing Z square. So first case I'm finding the lambda, and we have to see for which n values the same thing for helium also will come. So first we'll calculate 1 by lambda is equal to RH, that is Rydberg's constant, into 1 by, it is Lyman square, Balmer says 1 by 2 square, because for Balmer says it is uh, first line is 2 minus 1 by 3 square. So which is equal to RH into 5 by 36. By this lambda is equal to lambda is equal to 36 by 5 into RH, 36 by 5 RH. So we have to check for helium what values of helium transition for this. Only helium you'll get here Z square again. So this is RH into Z square. Z square means 4. So for helium, for any transition, RH into 4, then you'll get the answer. So the transition after observation, after doing, this is option based question. So into 4 we should not write here. Don't write that 4 there. It was wrongly mistaken. So now the answer is transitions. N2 is equal to 4. Sorry, N1 is equal to 4. N2 is equal to 8. I'm clearing the answer now. N1 is equal to 4, N2 is equal to 8 for helium ion. So that will be the same, and this answer will be definitely, I show you the answer now for helium ion. 1 by lambda is equal to 1 by lambda is equal to 1 by lambda is equal to RH into, so Z square for helium is 4 bracket 1 by 4 square 16 minus 1 by 8 square 64. Now if I solve this, you should get the answer 5 by 36 into RH. Let us see. That is equal to RH into 1 by 4, RH into 4, writing it neatly, into 16 and 64, LCM is 64. 64 is LCM, and 16 4 times 4 minus 1, that is 3 by 64. So 1 by lambda is equal to, here 4 by 64, it is 4 how many times in 64? 16 times. So 3 by 16 should get the answer 5R by 36. So check the answer. I think this is N1 is equal to 4, N2 is equal to 8. You just check the answer again, once again. Next question. They're going to pose theory of electronic energy of a hydrogen atom in the nth power orbit is given by En is equal to 21.6 minus 21.76 in 10 to the power of minus 19 by n square. Calculate the longest wavelength. So longest wavelength is least frequency of the light that will be needed to remove an electron from the third orbit of helium ion. So they have given third orbit of helium ion. So finally, again, you have to apply Rydberg's equation. First, you need to find the energy, and from that energy, first you find energy E is equal to minus 2.18 into 10 to the power of minus 18. This is actual formula, but here they have given energy of the electron is given by nth orbit is given by 21.76. So you have to use this value only. Just energy of electron, as they have mentioned, we have to use this value. En is equal to E is equal to minus 21.76 into 10 to the power of minus 19 divided by n square is given third orbit of helium ion. Helium ion is third orbit, so they have given 3 square, and here into z square. Z square means here helium is 2, so 2 square. So from this, you will get the value of energy. And how to get 2 square, that is 4. From this, you will get the value of energy of the electron in the third orbit of helium ion. And from that, you can find wavelength by using the formula E is equal to h into c by lambda. And you know value of h, you know the value of c, you know the value of energy. And finally, you can find lambda value. I hope this is clear. So you will get lambda value. Verify this like this only. Like this only you have to do. Since they have given the energy value minus 21.76, actually it should be 2.18 in 10 to the power of minus 18, but as they have mentioned, so we have to use that value as energy. And here 4 is nothing but how we got 4 here from helium ion, and 9 is nothing but orbit number, third orbit. So wavelength is E. After finding this energy, you can find wavelength of that particular energy. So E is equal to h into c by lambda, where c is called velocity of light, h is called Planck's constant. E value we will get from this expression, and lambda easily can find out. Now I'm writing the answer. So verify your answer whether it has come or not. So it should come as 205 nanometers. I hope this is clear. Next question. Which hydrogen-like ion has wavelength difference between the first line of Balmer series and first line of Lyman series equal to 59.3 nanometers? Once again, I repeat the question. Which hydrogen-like ions has wavelength difference between the first line of Balmer series and first line of Lyman series? So first, we have to write first line of Balmer series and first line of Lyman series equal to 59.3 nanometers. And they're asking wavelength difference between first line of Balmer series. So which hydrogen-like ion? So first already we know hydrogen ion. So hydrogen-like ion. So for this case, we have to write again Rydberg's equation. Rydberg's value is also given. So 1 by lambda 1 by lambda 1 is equal to RH into 1 by 1 square. This is Balmer's is no 1 by 2 square minus 1 by 3 square. This is for hydrogen like ion has given the difference between first line of Balmer series and first line of Lyman series. Next case, this is first line of Balmer series. Next case, 1 by lambda 1 is equal to lambda 2 is equal to RH into Z square, because hydrogen like species. We have to find hydrogen like ion. So first case I have taken hydrogen, and second case I have taken Z square because we don't know the atom. Z square into means bracket 1 by Lyman says first line 1 by 1 square minus first line of Lyman says means by 2 square. So we know by this we can compare lambda 2 and lambda 1. Lambda 2 minus lambda 1 is also given from the given equation. Lambda 1 minus lambda 2 is equal to 59.3 nanometers. So by using first expression, second expression, third expression, we can find out easily Z value. By using first expression, this is first equation, second equation, and third equation. By using 1, 2, 3 equations, we can solve for the value of Z, because RH we know they get cancelled, but only Z value is remaining. Remaining all the values we know. So Z value straight away we can get the answer. And if Z value is equal to 2, it is helium ion. If Z value is equal to 3, it is called lithium ion. If Z value is equal to 4, it is called beryllium ion. So let us see what the answer will come. So it is lithium plus 2 ion. So Z value you should get it as 3. Means Z square value should be 9. So just go through this. You do the same methodology. Next topic. Atom structure. Next topic. So I hope this is clear. Photoelectric effect and Bose is clear. We'll do more and more problems based on this entire chapter at the last. Now next concept is de Broglie theory of matter waves. So he proposed that all microscopic particles like electrons, protons, atoms, and molecules moving with high velocities. Here very important is high velocities. Underline these high velocities. I'm writing underline. You also underline these high velocities. The high velocities represent means already from Bohr's theory we know that electrons are moving with high velocity. Electrons are moving with high velocity. Electrons are moving with high velocity in a fixed orbit. So based on that, as the electrons are moving with high velocity, their movement of these electrons cannot be easily taken. So it should be taken as wave nature. And he proposed that it is wave nature. And the wavelength associated with the particle is given by lambda is equal to h by mv, that is equal to lambda is equal to h by p, where p is called momentum. Momentum is mass into velocity, as we already know. So this is called de Broglie wave equation, and from de Broglie's wave equation, lambda is equal to h by mv, or lambda is equal to h by p. Next. An electron is moving with a kinetic energy of 4.5 and 10 to the power minus 25 joules. Calculates its de Broglie wavelength. Mass of electron is given as 9.1 10 to the power minus 31 kg. Now, since the kinetic energy is given, from this kinetic energy we can find out easily velocity, because kinetic energy is equal to half mv square. So m is called mass of electron, v is called velocity. From this we can find velocity, and after, as they have given kinetic energy, we can find out velocity, and after getting velocity, de Broglie will be lambda is equal to h by m into v. So you can use these two formulas to find out the answer of de Broglie wavelength, and the wavelength should be in meters. After you get, because both joule and kg are SI units, so the wavelength whatever you get the answer is in meters, and you have to convert them into nanometers and axioms depending on the options. So I hope it is clear. So let us substitute now. In these both cases, half mv square is kinetic energy, and here lambda is equal to h by mv. So from this v square, so mass is also given here. So straight away we can substitute the formula and find out the answer. So the answer is kinetic energy by 2 into m, that is under root 2 into kinetic energy, not kinetic energy by 2. 4.5 in 10 to the power minus 25 divided by mass of electron, that is 9.1 10 to the power minus 31 kg. So after solving this, you'll get the value of V. Once you got the value of V, you'll get the answer of lambda. So this calculation part you can do, because 10 to the power minus 25 can be taken as 5 square. Like that, here also we should take 10 to the power of 30 or like that. So if you do this calculation part, it is easy. So next, the answer will be 726, 728.6 nanometers. It is coming nanometer. I hope this is clear for you. So this is problem related to de Broglie wavelength. Second question: a beam of alpha particles move with a velocity of 4.5 10 to the power of 3 meters per second. They have given velocity v, and they have given alpha particles. Calculate the de Broglie wavelength of the alpha particles. Mass of proton is given, mass of neutron is given. Why they have given mass of proton and mass of neutron? That also we have to discuss now. Since alpha particles have doubly ionized helium nucleus, since alpha particles are doubly ionized helium nucleus, that is He plus 2. So it plus 2 means it nothing but it contains two protons, and already you know helium has atomic number is 2, mass number is 4, so it contains two neutrons also, two neutrons. So in this case, total mass should be taken as 2 into mass of proton and plus 2 into mass of neutron. That's why they have mentioned these two. So mass is equal to 2 into mass of proton, that is 1.672 10 to the power of minus 27, and 2 into mass of neutron, that is 1.675 10 to the power of minus 27 kg. So this first you have to know the wavelength. We should know the mass also, because lambda is equal to h by mv. Lambda is equal to h by mv. They have given only velocity. We have to find out mass. Then I have to substitute. Already h is Planck's constant. Already we know. So lambda is equal to h by mv. Here mass is equal to, since alpha particle is very important here. Alpha particle is doubly ionized helium nucleus. Doubly ionized helium nucleus. This is called alpha particle. So it contains two protons and two neutrons. So by substituting the values of mass, you'll get total mass, and substituting the value of total mass into velocity and h you have to divide. Then you'll get the lambda value. So I hope this is clear. Lambda is equal to 21.9 picometers. 1 picometer is equal to 10 to the power of minus 10 meters. That also you know in the starting chapter only we discussed. Next question. What will be the wavelength of the tennis ball of mass 0.2 kg and moving with velocity of 20 meters per second? Straight question it is. They have given mass into velocity. So straight away, lambda is equal to h by mv, where h is called Planck's constant, that is 6.625 10 to the power of minus 34, and mass is given 0.2 kg. So all are in SI system only. So no need to change any unit. Straight away you can get the answer. So that is lambda is equal to h by mv, that is equal to 6.625 10 to the power of minus 34 divided by mass is, you know the mass, 0.2 into 20. 0.2 kg means you have to take 200 grams. No need to take directly 0.2 kg only. So no need to change the unit. If they are given in grams, you have to convert them into kgs. So 0.2 into 20 is, you'll get the answer. So this calculation part you can do. The answer should be 1.656 in 10 to the power minus 34. So this should be the answer. This is easily you'll get it because 6.0 to 6.625 by 4 is 1.656. Is it clear now? Next question. Very important. Heisenberg's uncertainty principle. What is Heisenberg uncertainty principle? It is impossible to determine the exact position and momentum of electron in an orbit because in Bohr's theory already we know electron is moving with high velocity. So where the exact position of electron or where the momentum of electron we cannot say simultaneously. This is only Heisenberg uncertainty principle. Moreover, it is a defect of or limitation of Bohr's theory also. So it states that the simultaneous determination of position and momentum of a subatomic particle like electron is impossible. The simultaneous determination of position you have to underline here, position and momentum. So position is represented by delta x. That is change in momentum, change in position, delta x. And delta p is momentum. So position and momentum, the simultaneous determination of position and momentum of a subatomic particle like electron is impossible in an orbit. So this is called Heisenberg uncertainty principle. And based on this mathematical expression is delta x into delta p. Delta x is called uncertainty in position. Delta p is called uncertainty in momentum. So that should be greater than or equal to h by 4 pi, where delta x is equal to uncertainty in measurement of the position, delta p is uncertainty in the measurement of momentum, and h is equal to Planck's constant. So this is clear for you. Now we will go to numerical of Heisenberg uncertainty principle. So the uncertainty in momentum is given by delta p is equal to m into delta v because mass of the electron is remain constant. So no need of changing into m into delta m, and there is no delta m also. So in space of delta p, we can write it as m into delta v. So delta x into m into delta v is greater than or equal to h by 4 pi. When you are solving in numericals, we can write delta x into delta v is equal to h by 4 pi m. The delta v is called uncertainty in measurement of velocity. Velocity can change, but mass never changes because mass of electron is same. So that's why delta p is equal to change in momentum is equal to mass into delta v, where delta v is called uncertainty in measurement of velocity. So either they ask us to find uncertainty in position or uncertainty in momentum or uncertainty in velocity in this regard. I hope this is clear for you. Next. Heisenberg's principle will rule out the possibility of definite path or trajectories of electrons in an atom because it is difficult to determine where exactly the electron is present in an orbit. So that's why it is ruled out the topic called definite path or trajectories of electrons in an atom. The path of the electron can be determined only if you know the position and velocity of the electron at a given instant of time. And thus, Heisenberg principle is a major blow for Bohr's theory. This is the one of the limitation of Bohr's theory that he could not explain Heisenberg principle because he explained that the electrons revolve around the nucleus in a fixed orbit called in a fixed path called orbits. But here from Heisenberg, we cannot say the electron is in particular orbit because it is impossible to determine simultaneously the position and momentum of electron in a fixed path that is called orbit. So this is the limitation of Bohr's theory also. I hope this is clear for you. Next. So in this class, we discussed about Heisenberg principle as well as we discussed about de Broglie's wavelength and we have recapped Bohr's theory and so on. So here doing I'm stopping this class. In the next class, we'll discuss other topics. Hope you understood it clearly.